Yes, dear student, just before this I had taught you about the velocities of particle 1 after collision and velocity of particle 2 after collision. How I got this value? This is the velocity of particle 1 before collision. That is, I can say this is velocity of approach and this is called velocity of separation. So from this equation and first equation which I had got from the conservation of momentum, by simplifying these two equations I will get value of this and this. How? Because from here I can substitute the value of v1 or v2 in equation number 1. If I will substitute the value of v1, so I can find out v2. If I will substitute the value of v2 from here to equation number 1, so I will get v1. So like this I will get v1 and v1 dash and v2 dash. Now this is very important. These both equations are very important for elastic collision in one dimension. But here now condition is given to you, let between the heavy and a light body. So it means one body is heavy and one body is light. Suppose m1 is heavier and m2 is lighter. Understood? So what is happening in this case? So m1 is heavier, m1 minus m2 upon m1 plus m2. So this is having more value and this is almost equal to m1. So m1 upon m1. So that is almost equal to 1 and that is 2 m2 upon m1 plus m2 is almost equal to how much? 0. And 2 m1 upon m1 plus m2 is almost equal to how much? 2. Substituting these value. How it is so? Because m1 is far bigger than m2. So subtracting a small quantity, it will not make any difference. And adding a small quantity in this, it will not make difference. So that will remain m1 and this will also remain m1. m1 upon m1 is equal to 1. So what is left here? Only v2. And here m1 and it is also how much? m1. So this will remain how much? 2. So 2v1 minus v2. So like this you will get 2v1 minus v2. So this is the value of v2 dash. If the one body is lighter and another body is heavier. Understood or not? So in this case, like this I can find out the value. In the second case, suppose m2 is bigger than m1. Suppose m2 is heavier in comparison to m1. So if m2 is heavier, so its denominator will become more and numerator will become what? Less. So that will become almost equal to 0. And here it will become m2 is more. So more I have to subtract from here. So this minus minus will become plus. So v2 dash is almost equal to how much? v2. Understood or not? So this inference we will get here. So v2 dash is almost equal to v2 if m1 is heavier in comparison, sorry, m2 is heavier in comparison to m1. Is this clear? Now second condition, elastic collision in two bodies of equal mass. Suppose both masses are equal. In that case what will happen? The velocity mass m1 is equal to mass m2. So in that case v1 dash is equal to v2. The velocity of particle 1 after collision was equal to or will equal to velocity of particle 2 before collision, and velocity of particle 2 after collision is equal to velocity of particle 1 before collision. So these three conditions are very important for you. Only you have to substitute the value of m1 and m2. You have to substitute the value of m1 and m2 in these two equations. If both are equal, again you can substitute the value. If one is bigger, another is smaller, so again you can substitute the value. So you can find out their velocity after the collision for inelastic collision. But elastic collision in two bodies of equal masses, the velocity will get exchanged between them. Now next you are studying about the perfectly inelastic collision. So this is inelastic collision in one dimension. So final velocity will remain same. It will become how much? V only. For both particles the final velocity will be same, that is v. But initial velocity was v1 and v2. What's the value of v? You can find out m1 v1 this. So this is the velocity of that. Understood or not? So at the same time you can substitute the value of m1 m2, whichever is bigger, whichever is smaller, like this. Now in this case, because it is inelastic, perfectly inelastic collision, so in inelastic collision there is always loss of kinetic energy. So how much loss of kinetic energy you can find out? So kinetic energy before collision and kinetic energy after collision. So you will subtract them, so you will get a value here. Understood? On simplifying this, have you got it like this? 1 upon 2 is constant. So this is m1 v1 square, m2 v2 square minus this is m1 plus m2 into v square. So v square will get multiplied here as well as here. What is v? V is this. Capital V is this. So substituting the value of v here. So I will substitute it here. So this will become this whole square upon m1 m2 whole square. This one, this will get eliminated. On simplifying this is very important. I will get it like this. On simplifying this, I got it like this, or simply m1 m2 v1 minus a minus b whole square and 2 m1 plus m2. So this is called loss of kinetic energy in case of perfectly inelastic collision. Understood? So that's all about this. And further, I have to tell you about the coefficient of restitution and elastic collision in 2 dimensions. Thank you.